Hello friends, welcome to True Event Academy. In this particular lecture, we will discuss about the constrained motion. So what is the constrained motion? The motion of a particle is called a constrained motion if it is compelled to move along a given curve or a surface. Okay, so let us take an example. So let us take a ball that is tied to a string. Okay, and now the velocity u is provided to this string. So what will happen here is that since it is tied to a string, it will follow a circular path like this. So the motion is constrained to move along a circular fashion. Okay, so this thread is a constraint here, constraint, and the motion is constrained to move in a circular fashion. Okay, let us take another example. Let us take a shell like this and let us put a ball here. Okay, now we give a velocity u to this ball. So what will happen is that this ball will move like this. It will move along the surface of this shell. So the motion is constrained to move along in this fashion. Okay, so this shell is a constraint here. Shell is constraint here. Okay, so let us analyze the forces that are acting on this ball that is tied to a string. Okay. So let us take a particular case where the ball is at an angle of theta. Okay. So let us consider the weight of this ball as m. So we have the downward weight of this ball, that is mg. We have tension that is acting towards the origin. Okay, because we know that the tension always acts away from the body. Let us consider this angle as theta. So we have this angle as also as theta. Okay. So we have this value as theta. So this is mg cos theta and this is mg sin theta. Okay, this is theta, so this is 90 minus theta. And here we have a normal acceleration as well as tangential acceleration. So tangential acceleration will lie in this direction and the normal acceleration will along the perpendicular direction. So we have the normal acceleration. Okay, so let us write the equation of motion. Okay, so we have the forces that are acting, forces acting on ball. Okay, पहला weight of the ball, that is mg. दूसरा, weight of this ball is acting on this force, tension towards center. Okay. Third, centripetal force. Okay, forces due to tangential acceleration. Force due to tangential. Okay, so these are the forces that are acting on this this ball. Okay, so let us resolve the forces acting on the ball. So let us resolve the forces along the acting on this ball. So along tangential direction, we have m. Let us consider this whole distance as s. Okay, so m d2 s upon dt square is equal to minus of mg sin theta. Okay, so let us cancel this m. So d2s upon dt square is equal to minus g sine theta. Okay, so let us take s is equal to let us take the radius as a. So s is equal to a theta. So we have a d2 theta upon dt square is equal to minus g sine theta. Okay, this is along tangential direction, and along normal we have this one. This is tension. Okay, so we have T minus mg cos theta is equal to m v square upon a. Okay, m into v square upon a is the force along the normal direction. Okay, so let us further simplify this. Let us multiply 2a d theta upon dt both side. Okay, so we have this one, the 2a square d2 theta upon dt square into d theta upon dt is equal to minus 2ag sin theta d theta upon dt. Okay, so dt gets cancelled here. So we have d of a d theta upon dt ka whole square is equal to minus 2ag sin theta d theta. Okay, let us integrate this. So we have a d theta upon dt whole square is equal to minus, this is plus 2ag cos theta plus constant of integration. Okay, d of, so let us integrate this. Sorry, this is already integrated na. So we have this as d theta by dt is a omega. So a omega whole square is equal to 2ag cos theta plus a. Okay, so we have v square is equal to 2ag cos theta plus a. Okay, so let us put the constraint here. So at theta is equal to 0, the initial velocity is u. Okay, so at theta is equal to 0, v is equal to u. So let us put this, u square is equal to theta 0 means cos theta is equal to 1, so 2ag plus a. Therefore a is equal to u square minus 2ag. Okay, so we have from here we have u square is equal, a is equal to u square minus 2ag. So let us put the value here. Okay, so let us rub this. So we have v square is equal to 2ag cos theta plus value of a is u square minus 2ag. So you have v square is equal to u square minus 2ag, 1 minus cos theta. Okay, so this is the value of velocity. Let us find the tangent here. Tension here. So from here we have T minus mg cos theta is equal to m upon a into v square. So v square value is this one. So this is u square minus 2ag 1 minus cos theta. Okay. So we have T is equal to mu square upon a plus mg cos theta minus 2 mg 1 minus cos theta. So this is equal to mu square upon a minus mg 2 minus 3 cos theta. Okay, 2 minus 3 cos theta. So this is the tension. Okay, so we have the tension as this and velocity as u square minus 2ag 1 minus cos theta. Okay, so what is our result? So we have velocity is equal to u square minus 2ag 1 minus cos theta. Okay, and tensile is equal to mu square upon a minus mg 2 minus 3 cos theta. Okay, so let us deal with the cases, few cases. Let us deal with few cases that are listed here. Okay. So let us deal the cases. Okay, in the first case, velocity becomes 0 before the tension becomes 0. Okay, this is case 1. Velocity and the tension becomes 0 simultaneously. Okay. Third case, tension becomes 0 before the velocity becomes 0. And now the condition for describing the whole cases. Okay, so let us deal this case by case. Okay, so let us deal the first case. So we have case 1 as velocity becomes 0 prior to so before dealing with the cases, let us proceed for finding the values of theta at which the velocity becomes 0 and tension becomes 0. Okay, so let us deal with the cases. Okay, so we have this as velocity is equal to 0 and tension is equal to 0. Okay, so let us find the cases. Theta 1, cos theta 1, value of cos theta 1 is equal to value of cos theta 2. Okay, when the tension becomes 0, value of h1, height from the bottom where the velocity becomes 0, height from the bottom where tension becomes 0. So let us find these values. Okay, after that we will proceed for finding the cases. Okay, so let us find. So we have v square is equal to u square minus 2ag 1 minus cos theta. Okay, so let v is equal to 0 at theta is equal to theta 1. Okay, so let us draw the let us understand this. Okay, so we have the circle like this. Okay, so this is our, let us consider theta is equal to theta 1 when v is equal to 0. So theta 1, at theta 1 v is equal to 0, velocity is 0. Okay, so this means the particle will oscillate about this a value, this point a. So it will keep on oscillating. So it will move like this. Okay, so this is move like in this manner because here the velocity is 0. And what will be the height from the bottom of this bottommost point? So this is the height, this is h1. Okay, so this is a. So what is h1? h1 is equal to a minus a cos theta 1. So this is a 1 minus cos theta 1. Okay, so let us find the value. So v is equal to 0, so let us put 0. 0 is equal to u square minus 2ag 1 minus cos theta 1. Okay, so 1 minus cos theta 1 is equal to u square upon 2ag. Clear? So cos theta 1 is equal to 1 minus u square upon 2ag. So this is equal to 2ag minus u square upon 2ag. Cos theta 1 is equal to. Okay, so cos theta 1 is equal to 2ag minus u square upon 2ag. Okay, now we have value of cos theta 2. So value of cos theta 2 when t is equal to 0. So now t is equal to mu square upon a minus mg 2 minus 3 cos theta. Okay, so when t is equal to 0, let theta is equal to theta 2. 0 is equal to mu square upon a minus mg 2 minus 3 cos theta 2. Okay, so 2 minus 3 cos theta 2 into is equal to mu square upon a into 1 upon mg. This is equal to u square upon ag. So 3 cos theta 2 is equal to 2 minus u square upon ag. This is 2ag minus u square upon ag. So we have cos theta 2 is equal to 2ag minus u square upon 3ag. Okay, so we have cos theta 2 is equal to 2ag minus u square upon 3ag. Okay, now let us find the value of h1 and h2. So we have value of h1 as, how we can find the value of h1? h1 is the height at which velocity becomes 0. So we have the motion like this. So here the velocity is 0, v is equal to 0. So what is the height from the bottommost point? This complete distance is a, okay, and this is theta, and this is a. So this distance is a cos theta, and this whole distance is a. So this is a minus, we have taken value of theta as theta 1 when the velocity is equal to 0. So we have a cos theta 1. So a minus a cos theta 1 is equal to h1. So h1 is equal to a 1 minus cos theta 1. Okay, let us find the value of h1. So h1 is equal to a 1 minus cos theta 1 is this. So this is 2ag minus u square upon 2ag. So this is the equal to a 2ag minus 2ag plus u square upon 2ag. Okay, so this is equal to u square upon 2g. This is h1. U square upon 2g. This is u square upon 2g. Let us find the value of h2. Okay, so h2 is equal to height from bottommost point at which tension is equal to 0. Okay, so we have here tension is equal to 0, v not equal to 0. We are taking a hypothetical case. Okay, so we have this whole distance, this is h2, and whole distance is this is theta, this radius is a, this is theta 2, this is a cos theta 2. This h2 is equal to a minus a cos theta 2. This is equal to a 1 minus cos theta 2. This is h2. Okay, so we have h2 is equal to a times of 1 minus cos theta 2. This is 2ag minus u square upon 3ag. This is equal to a 3ag minus 2ag plus u square upon 3ag. Okay, so this is equal to u square plus ag upon 3g. This is h2. U square plus ag upon 3g. So u square plus ag upon 3g. Okay, now let us proceed for the cases. Okay, so now we have calculated this table. So now we will proceed for the cases based on these values. Okay, so let us discuss the cases. Okay, so in the case 1 we have velocity becomes 0 prior to tension becomes 0. Okay, so we have like this. So this is our ball. Okay, so velocity becomes 0. So we have considered theta 1 as the value of theta when the velocity becomes 0. So this is theta 1. So we have here velocity is equal to 0, but prior to the tension becomes 0. So at theta 1 tension is not equal to 0. Okay, and what is height? Height, this h1 is the height from the bottommost point where the velocity becomes 0. So this is h1. So this is a. Okay, so this is a cos theta 1. So this is equal to h1 is equal to a minus this whole distance is a na, and this is a cos theta 1. This is a minus a cos theta 1. So this is equal to a 1 minus cos theta 1. h1 is equal to. Okay. So let us find the value. Okay, so in this particular case, we have the h1 will be attained prior to h2. So in this particular case, h1 is less than h2. h1 is the height at which velocity becomes 0, and h2 is the height at which tension becomes 0. So our case is the velocity becomes 0 prior to the tension becomes 0. Hence h1 will be less than h2. So let us do the calculation with respect to h1 less than h2. So we have the h1 less than h2. So h1 is less than h2. So we have u square upon 2g less than u square plus ag upon 3g. Okay, so this is h2. So we have 3g gets cancelled. So 3u square is less than 2u square plus 2ag. So we have u square less than 2ag. So u is less than root under 2ag. Okay, so if our velocity is less than root under 2ag, the particle will not reach the position that is on the horizontal diameter. Okay, so it will lie somewhere below this point. Okay, so this is the horizontal diameter. Okay, so if our initial velocity u is less than root under 2ag, so this particle will not reach this point B, that is on horizontal diameter. So let us consider this point as A and this is point as B. Okay, so this point, this particle will not reach this point B. Okay, so it will lie somewhere below the point B. Okay, and it will start oscillating about the point A, that is the bottommost point. So it will start oscillating like this. Okay, so it will not reach this point B. So let us write the conclusion here. So in case of this, okay, so in this particular case, u is less than root under 2ag and the particle will not reach the point on horizontal diameter. Okay, so let us consider the point on the horizontal diameter as B. Okay, so this will oscillate between this particular path. Okay, so this particle will not reach up to this point B. Okay, will not reach the point on the horizontal diameter. Okay, so let us calculate the cos theta, verify the cos theta 1. So at what angle this will be reached? So we have cos theta 1 as 2ag minus u square upon 2ag. Okay, and what is u square is less than 2ag. Okay, so this whole value will be positive. Okay, so we have cos theta 1 is equal to positive. This means theta 1 is less than pi by 2. Okay, so obvious this will not attain the so theta 1 will not attain the value of 90 degree. Okay, so this is theta is equal to pi by 2, and we have theta 1 is, this is theta 1, so theta 1 is less than pi by 2. So theta 1 is not equal to pi by 2. This means particle will not reach the point on the horizontal diameter. Okay, so let us discuss case 2. Velocity and tension becomes 0 simultaneously. Okay, so this means V is equal to 0 and tension is equal to 0. Okay, So in this case, what will happen is that h1 is equal to h2. h1 is the height at which velocity becomes 0, and h2 is the height at which tension becomes 0. Okay, so this is the height at which v is equal to 0. This is height at which tension is equal to 0. So we have h1 is equal to h2 because the velocity and tension becomes 0 simultaneously. Okay, so we have h1 is equal to h2. So h1 is u square upon 2g. So u square upon 2g is equal to u square plus ag upon 3g. Okay, so this gets cancelled. So 3u square is equal to 2u square plus 2ag. So we have u square is equal to 2ag. U is equal to root under 2ag. Okay, so if we give the initial velocity of u is equal to 2ag to the particle. Okay, so this initial velocity, it will reach to the point on the horizontal diameter. Okay, so let us verify this. So we have cos theta 1 is equal to 2ag minus u square upon 2ag, and we have value of u square as 2ag. So this is equal to 0. So theta 1 is equal to pi by 2. This means the particle will attain the height that is on the horizontal diameter. Okay, so it will reach up to the point B and starts oscillating about point A. Okay, so in the earlier case theta 1 was less than pi by 2. This means it was not able to reach the point on the horizontal diameter. But in case 2, where the velocity and tension become 0 simultaneously, the particle is able to reach point B and it starts oscillating about point A. Okay, so let us write the conclusion here. If u is equal to root under 2ag, the particle is able to reach the point on horizontal diameter. Okay, and it starts oscillating about bottom most point. Okay, so in this particular case, if u is initial velocity is root under 2ag, so it will be able to reach the point on the horizontal diameter. Okay, so this theta 1 is equal to pi by 2. Okay, let us discuss case 3. So we have this tension becomes 0 prior to velocity becomes 0. Okay, so we have the h2 as the height from the bottommost point at which tension becomes 0, and h1 is the point at which velocity becomes 0. Okay, h1 is the height from the bottommost point from where the velocity becomes 0. So h2 is attained prior to h1. So h2 is less than h1 because h2 is attained prior to h1. Okay, so we have h2 is equal to u square plus ag upon 3g is less than u square upon 2g. Okay, so 2u square plus 2ag is less than 3u square. So u square is greater than 2ag. So u is greater than root under 2ag. Okay, so in this particular case, if the velocity is greater than root under 2ag, then tension becomes 0 prior to the velocity becomes 0. So let us find the value of cos theta 2. So theta 2 is the angle at which tension becomes 0 as per this. Okay, so we have cos theta 2 is equal to 2ag minus u square upon 3ag. So u square is greater than 2ag. This means u square is greater than 2ag. This means this value is negative. This value is negative. Okay, so cos theta 2 is negative. This means theta 2 is greater than pi by 2. Okay, so theta 2 will lie on the point above the point B. Okay, so let us draw this. This is the bottommost point. Okay, so we have this cos theta 2 as negative. This means theta 2 is greater than pi by 2. Greater than pi by 2. This means it will lie somewhere here. Okay, this is theta 2 is greater than pi by 2. Okay, so at this particular point we have tension is equal to 0 but velocity not equal to 0. Okay, so at this particular point this string gets slacked. Okay, because the tension becomes 0, so it will leave the circular path and start following a parabolic path like this. It will leave the circular path. Okay, and it will move with a velocity say v. Okay, at an angle of inclination alpha. Okay, it will start following a parabolic path like this. And this angle will be, angle of inclination will be alpha. Okay, let us draw this again. So we have u square is greater than is greater than 2ag. Okay, based on the calculation of h2 is less than h1. Okay, so this comes based on the calculation from h2 is less than h1. So we have cos theta 2. Cos theta 2 is equal to 2ag minus u square upon 3ag. So since u square is greater than 2ag, so this whole terms is less than 0, that is negative. Okay, so this since cos theta 2 is negative, so we have theta 2 is greater than pi by 2. समझ में आ रहा है? So this point will lie in above the horizontal diameter. Okay, so let us draw the theta 2 greater than pi by 2. This is the bottommost point. Here the u is greater than root under 2ag. Okay, and this is the angle theta 2. Okay, at this particular point we have tension is equal to 0 but velocity not equal to 0. Okay, so at this particular point the tension is 0, so the string will get slacked and it will leave the circular path. Okay, so since it leaves the circular path, it will follow a parabolic path. Okay, just like a projectile motion. So it has a velocity v. Okay, so we have a velocity v and the angle of inclination from the horizontal is alpha. Okay, so at this particular point tension is equal to 0, so the string will get slacked and it will follow the parabolic path. Okay, like this, and velocity is not equal to 0 here. Okay, so let us write down the conclusion here. So in this particular case, what will happen is that particle will here u is greater than root under 2ag. Okay, and particle leave the circular path and follow the parabolic path. Okay, so it will follow the parabolic path like this. Okay, so let us deal the case number 3. Sorry, this was case number 3, no? This is case number 3. Okay, so let us discuss case number 4. Case 4. What is case 4? Condition for describing the full circle. Okay. Condition for describing the full circle. So what is the condition? Let us write down the, let us find the what will be the velocity and what will be the tension at topmost point. Okay. If the let us find the velocity and tension at topmost point. So we have v square is equal to u square minus 2ag 1 minus cos theta. Okay, so here theta is equal to pi. So v square is equal to u square. So theta is equal to pi. This is minus 1. So this is u square minus 4ag. Okay, so this is v square. Okay, so this is the value at theta is equal to pi. Okay, now tension at pi is equal to mu square upon a minus mg. This is theta is equal to pi. So this is minus, this is 5. This is equal to mu square upon a minus 5 mg. Tension at pi. Okay, so if u square, if u is greater than 5 ag, okay, then neither v is equal to 0 nor t is equal to 0. So if we give the velocity u is equal to root under 5 ag, greater than 5 ag, then at this particular point neither v is 0 nor the t is 0. Okay, so this is obvious now. Here we have u is greater than 5 ag. This means u square is greater than 5 ag. So if we put here 5 ag, this is ag. And here if u is greater than 5 ag, then t is also not equal to 0. This means if we give a velocity of u greater than 5 ag, then it will describe the complete circle. Okay, so let us check at u is equal to 5 root under 5 ag. Okay, so if u is equal to 5 ag, so we have v pi whole square is equal to 5 ag minus 4 ag is equal to ag, not equal to 0. But tension at pi is equal to m upon a into 5 ag minus 5 mg. This is equal to 0. Okay, so if u is equal to 5 ag, then at topmost point we have velocity is equal to ag root under ag, and tension is equal to 0. So at this particular point, if the initial velocity is equal to root under 5 ag, then the particle the tension becomes momentarily 0, but velocity is not equal to 0. Then it will be able to describe the complete circle. Okay, so the condition for describing the complete circle is u is greater than equal to 5 ag root under 5 ag. Okay, so if the initial velocity is equal to 5 ag, then at topmost point v is not equal to 0, but tension is equal to 0. Hence at this particular point the string gets momentarily slacked, but since the velocity is not equal to 0, it will be able to describe the complete circle. Okay, As simple as that. Okay, so what happens in the case 4 is that if u is greater than root under 5 ag, then neither velocity becomes 0 nor tension becomes 0. ठीक है. If u is equal to root under 5 ag, then v not equal to 0. Okay, that is equal to root under ag, but tension becomes 0. So the string gets momentarily slacked at topmost point, but it is able to describe the complete circle. Okay, so this is the condition for, hence the condition for describing the complete circle is, hence the condition for describing the complete circle is u greater than equal to 5 ag. Okay, as simple as that. Okay, let us discuss the case 3 once more. What was there in case 3? Tension becomes 0. Tension becomes 0 prior to velocity becomes. Okay, so in this particular, what was the case? We have u greater than root under 2 ag, but less than root under 5 ag. Okay, that is u greater than root under 2 ag, but less than 5 ag. Okay, so in this particular case, this theta 2 is greater than pi by 2. Okay, so at this particular point it will, because here v is not equal to 0 but tension is equal to 0. Velocity is still there in the ball, so it will leave the it will leave the circular path and start following the parabolic path. Okay, at an angle of alpha. Okay, so what we have to remember here is u is less than 5 ag but greater than root under t ag. Okay, so if u is equal to root under 5 ag, or if u is greater than equal to root under 5 ag, then it will be able to draw the complete circle. Okay, so let us write down the conclusion at a single place. Okay, in a tabular manner. Okay, so I will write here itself. Okay, so velocity becomes 0 before the tension becomes 0. So in this case we had h1 is less than h2. Okay, and here we have velocity and tension become 0 simultaneously. So we have h1 is equal to h2. Tension becomes 0 before the velocity becomes 0. So we have h2 is less than h1. Okay, and this is condition for describing the full circle. So in this particular case, what was the result? Velocity becomes 0 prior to tension becomes 0. So in particular case, u is less than root under 2ag. Okay, velocity and tension becomes 0. So here u is equal to root under 2ag. Okay, tension becomes 0 before velocity becomes 0. So u is greater than root under 2ag but less than root under 5ag. Okay, and condition for describing the full circle is u is greater than equal to root under 5ag. Okay, and here theta 1 is less than pi by 2. Here theta 1 is equal to pi by 2. Here theta 1 is greater than pi by 2. Okay, and this is the condition for describing the full circle. Okay, so we have discussed the constraint motion in detail. Okay, so we will start discussing the questions in the next particular lecture. Okay, thank you.